Hi, uh, this video is to demonstrate how to create a CAD model of twin screw compressor using SolidWorks. So in this slide, the diameters of this twin screw compressor is shown here in this table, and the rotor profile is shown in the right corner figure. So this twin screw compressor has the three 5-loop combinations. So there are 5 steps to create the CAD model. So the first one is to insert the coordinates. So the coordinates just has the one loop of the each router for main and gate router. And the second step is to create a helix line based on rotor length and the lead. The third step is to create a swap rotor profile along helix line. Fourth step is to create the casing. And the last step is to mate the rotors. So first of all, we open the SolidWorks, and the first step we need to insert the coordinate. So insert curve and the curve through XYZ points. So we need to browse, and here because our coordinates is a txt file, so we need to choose txt. So P1 is for the main router. We open it, then we can see the XYZ coordinates are imported. The Z coordinates are 0. So here we have one loop, and now we need to create a sketch. So first we need to convert this line to entity. So we use the convert entities. Now this loop we can use it to circular sketch this loop and choose this loop. Now, because as we mentioned earlier, there are 3 loops for the main router, so we input here 3. That's it. So after pattern this feature, we notice that they are not connected. So we need to manually connect this curve. If your router profile is fully closed, then you don't need to do this. And be careful, you need to connect this point to make it closed. Now we can see it's fully closed. So we have the full router profile now. And then second step to create a pitch circle for as the reference of the helix line. So we draw a circle. And the dimension of the pitch circle as shown here, which is the pitch diameter, which is 69.75. So we give a dimension of this circle 69.75. So this is the pitch circle for the main router. So then we use this circle to create a helix line. So it's same as insert, curve, and helix spiral. So there are many options to create the helix line. You can create from the pitch and the revolution, height and the revolution, height and the pitch. So we use the height and the pitch here. And the height as in the table shown is the root length, which is 213.042. So we input here 213.0442. And the pitch for the main router is also shown in the table, which is the lead here, which is 255.65. So we input here, which is 255.65. and we make it clockwise or anti-clockwise. For the main router and the gate router, the direction is different. So we can choose counterclockwise or clockwise. It depends on the rotation. So here we choose the counterclockwise for the main router because it needs to rotate clockwise. And starting angle we can choose 0. So this is a helix line for the main router. And then we need to swap this router profile along the helix line. So here is the curve you want to swap, and the direction is a helix line. So now we create the main router 3D model. Okay, it looks fine. And because we want to mate the main router with the casing, so it's good to create a axis now. And we make a sketch for the axis, center, create this dash line. Yeah, and also because we want to create the gear ratio between the main router and the gate router, so it's good to create a helix, another pitch circle for mate of the pitch circle between the main router and the gate router. So you see, we use the front plane for the pitch circle, use circle and draw. As we mentioned earlier, the pitch diameter is 69.75. So we just define this 69.75. Okay, that's all we need for the main router. So we can save it as the main router. Okay, then we use the same step for the gate router. Create a new part. And same step. First, we need to insert the coordinate of the gate router. Browse and use the txt file, which is p2 for the gate router. Now we have this one, and we need to create a sketch to convert it entities, and then use the circular sketch pattern here to circulate. And there are 5 loops for the gate router, so we need to input here 5. Okay. Yeah, it has same issue. We need to connect these 2 points manually. 1, 2, 3. As mentioned earlier, if your router profile is fully closed, then you don't need to do this. After connecting all these points, this profile will show fully closed. No, because we didn't connect these 2 points. Yeah, now you can see it is fully closed. And this is a gate router. Yeah, and then we need to create a pitch circle for as the reference of the helix line. We draw a circle from the center here, and the diameter of the pitch circle for the gate router is 116.25. 116.25. Yes. Maybe it's more inconvenient to create another one because we know we need another one of the pitch circle, so we can choose the pitch circle and convert entities. Then we have two pitch circles as reference. So the first one, then the next step we need to create the helix line. So insert helix line, you can use the first sketch of the pitch circle, and the height is the same for the both routers. So we use root length 213.042 and the pitch diameter no is and the lead is 426.083. So we input here the height is the same and the pitch is 426.083. And because the main router is counterclockwise, so the gate router is clockwise. Now we have the helix line for the gate router, and then we need to swap the gate router profile along the helix line. Yes. Then last step is to create axis for the gate router. Just you need to make sure this this line is vertical, so you just set as vertical. Okay. So now we have the gate router. We can save it. So now we have a main router and a gate router. The third part is the casing. Need to create another part for the casing. So for the casing, we need to draw a circle first. The origin we need to set as the global origin. Start from here and draw a circle, because the casing also has another circle. We draw here together, and the center of the circle should be horizontal, and the center distance for this is 93, and outer diameter is 120. For main router, the outer diameter is 125.319. So to make it easier, we can use 126, and for the gate router is 121. So we give the dimension of this outer circle. So for the main router is 126, and for the gate router is 121. Okay, because we don't need the curve in between, so we can use the trim function to just delete trim. And the center distance of the main router between two axes is 93. Let's give this dimension 93. Yeah. Now we can extrude this one with the same length of the main router and gate router, which is the 113.042, and because it should has the same function, just scale to 1. Because we want to mate the axis of the casing and the router, so it seems we need to create this axis for the casing. Another one. And also we need to make sure this is vertical. and also this one, so vertical. Okay, and the center distance is 93. Yeah, now we have this two axes. Yeah, just to have a check. Yeah, it's fine. Then we just save it as casing. Then we need to create the assembly. And the first step, we need to, I think it's better to insert the casing. And the first part insert the origin is not overlapped. So I think we need to, and also the first part is fixed. So I think we need to make it float because we want to mate the origin of the casing with the global origin. So this is a global origin and this is a casing origin. So now they are overlapped. And then we can insert main router. So now we have the axis, right? So the first mate for the main router is to mate this axis. Because as we know, the main router is on the left-hand side. So now the axis is mated, and also we want to move this the plane aligned with the casing plane. So we need to create another mate is the front plane of the casing and the front plane of the main router. This is the third mate. And now the main router is fine, and then we insert the gate router. First, we made the axis for the gate router, and the second to make the front plane of the casing and the gate router. Okay, now is they are made together, but now the main router and the gate router can rotate freely along their axis. What we want to do is to the main and the gate router rotate based on the gear ratio, which is 3 to 5. And to do that, we need to create a mechanical maze is a gear. There is a gear here, so we need to use the pitch circle we have drawn earlier. And the gear ratio, because we know is 3 to 5, or 4, yeah, we can to make it more accurate. We just input the gear ratio here. Okay, so we have created all the mate, and in total we have created 6 mates. This fully defines the rotation of the routers. And when rotate the main router clockwise, anti-clockwise, you see, or from this side, yeah, it's clockwise rotation. So we are done for the mate, and To check it, we can use this cross section view, and from the middle to check the clearance. Okay, we can see they are working well, so you can see the clearance between the gate router. So that's the video about the uh, CAD model or creating the CAD model or turn screw compressor. I hopefully you can learn something from this video. Thanks.